In this video, we will look at simplifying expressions using our exponent properties. You recall the 9 exponent properties we have seen. The power rule says we add the exponents, m plus n. The quotient rule says we subtract the exponents, m minus n. The power rules say that the exponent goes onto each factor in the expression. Again, noting that this only works if there is no adding or subtracting. Power of a quotient, again going on to each factor, a to the m over b to the m. And the power of a power says the exponents multiply together, giving us a to the mn. Anything to the 0 is always 1, as this means the factors have divided out. A negative exponent moves the a to the m to the denominator, now with a positive exponent. Similarly, if the negative exponent's in the denominator, it moves to the numerator. Or if the negative exponent is on a fraction, the fraction will flip over, making the exponent positive. As we simplify expressions using these properties, we will keep in mind the order of operations to allow us to simplify as much as possible. So, for example, on this problem, order of operations says we need to do the exponents first, as there is nothing to simplify inside the parentheses. The exponent, using the power rules, will go on to each factor. As it does, we will multiply exponents, and on the numbers, consider 4 squared is 16, x to the 10th, y to the 4th, z squared, multiplying those exponents, times 2 to the 4th, which is also 16, x to the 16th, y to the negative 8, z to the 12th, multiplying our exponents together. As we continue simplifying, 16 times 16 will give us 256. On the variables, we will add the exponents. On x, 10 plus 16 is 26. On y, 4 plus negative 8 is negative 4. And on z, 2 plus 14, or 2 plus 12 is 14. To finish, the negative exponent means the y has to move to the denominator, making the exponent positive. For our final answer, 256 x to the 26th, z to the 14th, over y to the 4th. We know our expression is simplified when each variable appears once, and there are no negative exponents. Let's consider another example. In this expression, again we see several exponents outside the parentheses. Using the power rules, we will put those exponents through, multiplying the exponents together. 2 to the 4th is 16, x to the 8th, y to the 12th, times x to the negative 8th, y to the positive 12th, multiplying our exponents by negative 2, over x to the negative 12th, y to the 8th. Continuing to simplify in the numerator, we can combine our x's together, giving us 16x to the 0, adding the exponents, and combine the y's together, giving us y to the 24th, over x to the negative 12th, y to the 8th. Recall that x to the 0 is 1, and x to the negative 12th needs to move to the numerator. We now have 16 x to the 12th, y to the 24th, over y to the 8th. To combine the y's together, we will need to subtract their exponents. When we do, we end up with 16 x to the 12th, y to the 12 minus 8 is 4. And this becomes our final solution. We can combine all the exponent properties together in a single problem, keeping in mind order of operations to simplify so each variable appears once and there are no negative exponents.